Okay, this again is a question from 2024, and this is actually based on a question which came in the year 2023. But that question which came in the year 2023 was very hard. This is comparatively extremely easy. Okay, this question is based on even and odd. So actually, before starting this problem, let me just run through even and odd. Any number which is divisible by 2, that is known as even number. For any integer that is divisible by 2 is known as a even number. So that can be 2, 4, 6, 8, 10. It keeps on going. It can also be minus 2, minus 4, minus 6, minus 8, minus 10. It can also be 0. So all these numbers are divisible by 2. Therefore, they are known as even numbers. And one more thing about the even numbers is that all the even numbers could be represented in the form of 2 into n, where n is any integer. So 2 into an integer, that is a form of an even number. Similarly, odd number, it will not be divisible by 2. And when you divide by 2, you are going to get a remainder of 1. Therefore, an odd number is not divisible by 2. When you divide by 2, you are going to get 1 as a remainder. You know that equation, dividend is equal to divisor into quotient plus r, the same thing. Now, one more equation is there. It's like adding 1 or subtracting 1. Both have the same effect. Okay, both are the equation of odd. Some examples are 1, 3, 5, 7, 9 and so on, and also minus 1, minus 3, minus 5, minus 7, minus 9 and so on. Okay, so this is even and this is odd. Now, the real problem comes when you take the combinations of these stuffs. So, if you add two even numbers, okay, or yeah, if you add two even numbers, even plus even, for example 2 plus 4, you will always get an even number. Similarly, if you subtract two even numbers, 2 minus 4, you will still get an even number. Addition or subtraction doesn't matter. If only even are there, even if it is 2, 3, 4, you are always going to get an even number as the result, because all these numbers can be expressed in the form of 2 into something. Okay, therefore you can take that 2 common outside, this 2 common outside, and write whatever it is. So this part anyway is going to be an integer, and therefore this will be in the form of 2n. So any number of even numbers, addition or subtraction, anything, you'll still going to get even in the result. Now let's look at the case of odd. If you're taking the same case with respect to odd, that is odd plus odd is going to give you an even number. Example, 1 plus 3, you're going to get 4. Or odd minus odd is also going to give you an even number. 1 minus 3, that is minus 2. Why is this happening? Because each of this number have a 1 extra. Okay, so if I can write the first number as 2 into 0 plus 1, and the second number, this 3, as 2 into 1 plus 1. If you look at this part, this thing and this thing could be taken together. This is a very bad example. Let me change the number from this to something bigger. Okay, it will be easier to understand that way. So if that is example, then this value is going to become 2 into 2, I guess. Yes, 2 into 2 plus 1. Now you can take these two values together. It's going to be 2 into 2 plus 2 into 1. And if you look at this ones, this one and this one will combine together. 1 plus 1 will become a 2. Now you can find 2's common anywhere. You will take that thing out. You will have the remaining 2 plus 1. And here also 1 will be there, because 1 is always there. 1 is a god of numbers. So you're going to get 2 into something. So if it is 5, 6, 7, it's going to be 8. Here also you're going to get 8. So what just happened? What happened is that this first odd number had a plus 1 extra. This second guy also had a plus 1 extra. These two plus 1s combined to become a 2. Therefore, that extra plus 1 is gone. I just told you that a number is inherently even. When an integer is inherently even, but it becomes odd because of this plus 1 or minus 1. So that get handled. If two of the odd numbers come together, it get handled. The same thing happens with this case also. I'm taking another example. Let's take the number 7. 7 minus 3. What is it? it's going to be 4. Why? 7 could be represented as 7 could be represented as 2 into 3 plus 1. Similarly, 3 could be represented as 2 into 1 plus 1. Okay, now this 2 part will come as it is. This minus will go inside. I can simply remove this bracket. Minus will go inside and everything is going to become minus. This will become minus, this will become minus. Now if you look carefully, these 2 parts will combine together to form 2 into 3 plus 1. And this part, this 1 and this minus 1 will get cancelled. And similar, the final answer will be, wait a minute, why am I getting, oh, it's not plus, it's minus. Yeah. So final answer is going to be 2 into 2, which is 4. So here also, the first value had a plus 1. This value had a plus 1, but after minus, it became negative, and this 2 got cancelled out. Therefore, it is getting even. Okay. So when odds comes in pairs, in addition or subtraction, it is going to become even. But the problem is that when odds come in, or now let's look another case where I'm taking one odd and another even. Odd plus even. For example, 5 plus 4. Okay. 5 plus 4. Oh, that's okay, fine. Let it be. You're going to get an odd number. Why? The 5 is nothing but 2 into 2 plus 1. And the 4 is simply 2 into 2. Now, if you look at these two values, the 2 into 2 and 2 into 2 will of course combine to form 2 into the first 2 plus second 2, 2 plus 2. And the remaining 1, that no one is there to take care of this guy. He is going to simply exist like that. So you will find this as 2 into 4 plus 1. That is 2n plus 1 format. This even number, the even number which you saw first, this even number is only 2n. It does not have any extra ones. But when you look at this guy, he have a plus 1 and no one is there to handle that. That will come as it is to the output also. Therefore, you are going to get an odd number as an result. Now, you can remember it as like this. Even numbers in addition and subtraction will not do anything. It will just come as even only. But odd numbers, if odd numbers are coming in pair, even if it's in addition or subtraction, it is going to become even. But if odd numbers are, any single odd number is there, it is going to become odd. So let's take an example. I will take one scenario where one odd number plus another odd plus another odd plus another odd plus another odd. I want to know, these are not zeros, okay, all are odd numbers. The result, I want to know what is going to be. If you look at this, you try to answer this problem. You can pause the video. Okay, now I'm going to give the answer. These two odds will combine to form an even number. These two odds will combine to form an even number, and there is a single odd. That single odd will generate an odd. So this is going to become something like this. Even and even is always even. Single odd will always create an odd. Okay. Now one more input which I want to add is that in case of addition and subtraction, you don't have to worry about it. Since we are only looking for the flavor of the number, we are only seeing if the number is even or odd. We don't have to know the exact number. Therefore, even if it is even if it is addition or subtraction, the same rule applies. That means, imagine this is minus, the between one is plus, or this is minus and between this one is plus. Still, this rule apply. Even odds are coming in pair, it's going to be even. Odds are coming in pair, it's going to be even. And this minus, you can just consider it as plus. Just change everything to plus, because in the result finally will be same. Again, I'm telling, the exact values will be different. Exact values will be obviously different, but we don't care about the exact value. We only need to know the flavor. Okay. So whenever it is plus or minus, you can just take it as plus itself. So this is the thing with addition and subtraction. Now the multiplication rule, I'll directly say even into even, it's going to be even, because you only need one multiplication with 2. Like this is in 2n form, this is also in 2n form. The result will obviously be in 2n form. Okay. an example, 2 into 4 is going to be 8. Or even into odd, this is also going to be even because this guy have an extra 2. That is going to come as multiplication itself in the final result. Example, 2 into 3 is going to be 6. The inverse, that is odd into even, that is also even. Okay, 3 into 2 is also 6 because the direction doesn't matter. Now the next part which we have is odd into odd. This is going to be odd. This is the only case we are going to get odd because both the numbers does not have any extra 2's. The number example 3 into 5, you are going to get 15. You see, this is the only place you are going to get an odd. Okay. So when you multiply even with any number, it is instantly going to become even. That's a thing to know. Whenever you multiply even a single even comes, then their result is going to be even. For one example, if I want to see is that 253 raised to 577. What's the value of this? Is it even or odd? The answer is going to be odd because it is 253 into 253 into 253 into such 577 times. It is basically odd into odd into odd into something like odd. Entirely it is odd. You are going to get a result of odd. Okay. Even if the power is something else like 252, the still result is going to be odd. The power doesn't have any power over here, even because that is only representing the number of times it is getting multiplied. Eventually it is happening like odd into odd into odd. Similarly, 244 raised to 353, what will it be? Even or odd? It's going to be even. Why? It is simply 244 into 244 into blah 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 till 244. It's basically even into even into even into even. It's going to be even. The only thing which you have to note is that whenever power is coming, this you only have to look at the base. If it is odd, the result also will be odd. If it is even, the result also will be even. And this only apply when the power is a natural number. That means when the power should be a number like 1, 2, 3, 4, something like that. If the power is 0, or if the power is some point values, or if the power is some negative values, then we cannot say, because we won't even know. If it is 0, then the number is going to become 1 when the power is 1, like 32 raised to 0 is 1. So that is going to be odd. But in other cases, we won't even know if the number is going to be an integer or not. So we can't say the answer. Okay. Now one more thing is that is about division. Usually I have not seen such questions asked till now, but still I'm going to just run through that. Even by even, we cannot say. Okay, it might be even, it might be odd, it might not be even divisible also. That means if it is not integer, we cannot say. If it is even by odd, okay, let's assume that every cases which we are taking is actually divisible. Even by odd, if it is divisible, it is surely going to be even. Odd by odd, if it is divisible, it is going to be odd. And finally odd by even. Odd by even is never ever divisible. Okay, that's a simple case. So just learn it as it is. You can just try it out with some examples like 4 by 2. Try to take divisible examples. It's an even. Or 6 by 3. Yeah, it's an even. Or 15 by 3. It's an odd. And if you take any example, you will not be able to find an example where you can divide odd with an even. 7 by 2, 3.5. See, this is neither even nor odd because that is not an integer. Now we can actually answer this problem. Yeah, this problem only needs some prerequisites. P, Q, R and S be distinct positive integers. P, Q, R, S be distinct positive integers such that P and Q are odd. P and Q are odd. P and Q are odd. R and S be even. These two numbers are even. Consider the following statement. So I am going to take the first statement, number 1, which is P minus R square into QS. They are saying it is even. Let me correct this. It doesn't look beautiful. Yes. They are saying that it is even. You should know they are not saying it can be even. They are saying it is even. Is a arrogant statement. They are basically telling us that it is always even. Okay. So to solve this problem, I'm going to solve it. First of all, I'm going to take everything as plus because minus or plus, it's not going to make any difference. Now let's see. P into Q. P is an odd number, R is an even number. P into odd into R square into Q is an odd number, S is an even number. Now, if you look inside the bracket, odd plus even is simply odd. Odd square into even. This is, see, this part is going to become odd square. This odd is coming here, even is going to come here. This entire part is going to be odd. That doesn't matter. Even if a single even is getting multiplied, you are going to get even. You can also solve this problem by substitution. Instead of doing this thing, you can simply substitute some values. For example, odd you can take, let's say, 1. The next odd you can either take the same number or you can take a different number, 3, just like 2 and 4. If you substitute these values also, you are going to get the same scenario. P plus R square. P plus R square. P is 1, R is 2 whole square into Q, that is 3 into 4. If you do it, you are going to get 3 square into 3 into 4. You can find this value. It's going to be 27 into 4. And whatever that result is, it's going to be even. 4 is coming. Okay, such problems are easier to do without substitution actually. That's why I didn't select. So anyway, this is always even. So statement 1 is actually correct. Statement 1 is actually correct. It is always even. So statement 1 is correct. Statement 2. Let's look at statement 2. Okay, I think I'll have to replace it below. Let me push it down. Okay, it went away. Now let's take the statement number 2. Statement 2 says that Q minus S into Q square into S. This is always even. Okay. So I can directly give you the answer. See, we already know that S is even. If we are multiplying a number with an even number, okay, if we are multiplying a number with an even number, so instead of this S, it is simply going to be even multiplied by something. In these are anyway going to be integer, so the result is also going to be even. You don't have to think much. But if you want to do, you can still do. Minus plus doesn't matter. You can take whatever you want. So Q was odd plus S was even into Q is any odd. So if you look at this part is going to be odd plus even is odd. Odd into odd square into even. If a single even is getting multiplied, the entire result is going to be even. You can even substitute the values and check. Okay, this is always going to be even. So statement 2 is also correct. Now we have to go for statement number 3. Let me just move this thing aside. Okay. Now let's take statement number 3. Statement number 3 says that Q plus R whole square P plus into P plus S is odd. Again, it's an arrogant statement. It should be always true. So P plus R, P and R. P is odd, the other one is even. Odd plus even whole square into P plus S. P, oh wait, this was Q. Okay, it was Q. Okay, anyway, it is still odd. Odd plus R is even. P is odd, S is even. See, now if you look at this thing, you will see odd plus even is odd. Odd square into odd plus even is odd. Odd square into odd is simply odd into odd into odd. When multiplication is happening, odds doesn't have any 2's with them. So your result is also going to be odd. So this is always odd. That is also true. You can also substitute the values and check. Okay. So if we have substituted the value like 3, R is 2, and P is 1, S is 4. You can check this value 3, 4, 5. 5 square into 5, that is 5 cube, which is 125. It's going to be odd. It's always going to be odd. So all the statements are correct. The question which came in 2023, that is much more interesting than this, because there they doesn't say exactly which one of these values are going to be even or odd. Okay, for example, I'll just make a question for your practice which is in the line of 2023. P, Q, R, S. Four numbers are there, four integers are there. What I'm going to tell you is that three of them are odd. Three of them are odd. And you have to figure out, I never told you which three of them are odd. Any three of them, some three of them are odd. And the question is P plus Q plus R plus, or let's replace one values, R minus S. P minus Q plus R minus S. I'm saying this can be even. This is the question. Okay, you try to answer if the statement is correct or not. I want you guys to answer if the statement is correct or not. You can pause the video and try to answer. Okay, I'm going to give you the answer. You can pause the video for more time. Okay, first of all, the first thing which I'm going to do is convert everything into plus, because it's not going to change the answer. Now, once everything is plus, then it's easy to do. I simply have to substitute odd. Three of them are odd. I'm going to substitute any three of them as odd and one even. I told you, if these two odd plus odd is going to become even, a single odd is there. Whenever single odd is there, the final result is always going to be odd, because this even and this even will combine to form even plus odd. See, this is simply odd. The answer is going to be odd. You can also substitute values after converting everything into this thing. You can say that 1 plus odd plus odd plus odd plus even. This is going to be 5. See, that's all. That's odd. It can be. It's a humble statement. Even if a single example happens, then it will be true. But this is wrong. It is always odd. One more problem. The same problem. I'm going to same scenario. Okay, same scenario. And the statement which you have to check is if 2p plus 4q minus 8r plus 12s, it is definitely even. That's a question. It is definitely even. You have to say if it is true or not. You can pause the video and try to answer. Okay, I'm going to give you the answer. What you have to do, first of all, convert everything into plus. And just look at this. Whenever 2 is getting multiplied with anything, this is an even into some number. This is instantly an even number, because p is any integer. We know that they are integers. It's given in the question. I mean, I have not said it here, but I have written it here, but I have told you. So p is an integer. Integer multiplying by an even number automatically become even. It doesn't matter what p is going to be. Similarly, 4 is an even number. Even into any integer is going to be even. Even into any integer is even. Even into any integer is even. Everything is inherently even. Even plus even plus even plus even is definitely going to be even. It's always even. So this statement is also correct. So that's it with even and odd. Thank you, people.